Here we have chapter 6, another example problem, and this is another design problem, and what we want to do is design a circuit whose output indicates when one and only one of the four inputs is a 0. So this is first step in every circuit, draw the black box diagram, so we'll do that. It has four inputs. We'll call them A, B, C, D. To keep it short, not overly expressive. Common output here is an F, and that's our first step, and this is the BBD, high level BBD. Next step is to draw a truth table to represent this. Remember, this is brute force design. I think I'm going to start this table off up here, A, B, C, D. Okay, here I am magically back after this thing has been drawn. And okay, first thing to notice, it has four inputs, so this has 2 to the 4th possible combinations. So this truth table has 16 rows in it. So if it had 5 inputs, I would have to draw 32 rows, and seriously, I don't think ever in my life I've done a 32-row truth table, and if you have to do that, you're doing something wrong. Pick another design method. Okay, so what I'm looking for is each of these columns where there's only one of the bits is set. And okay, here's my first column. I'm going to indicate that with a 1. Oh, there's the second one. Okay, wow, there's the third one. And look, scanning down here, and there's the fourth one. So there's 1, 2, 3, and 4. Everything that's not a 1 is a 0. Looking good. So at this point, I've got a truth table. This is my truth table. This is a valid model of the circuit, and this is a valid model of the circuit. They both give a little bit different information. What I'm interested in now is writing an equation for this. F equals A, B, C, D. I know each of these terms has an A, B, C, and D in it. There's 4 1s in this column, this F column. So there's going to be 4 A, B, C, D terms plus E. After I have that written, now I'm going to go look at it. Essentially, 2 ways to do this. You can look at this row, okay, there it is, and this is kind of the way you've learned, etc., etc. And here, but it's almost more intelligent to reason it out at this point. So this is the term where the D input's a 1. This is the term where the C input's a 1. This is the term where the B input's a 1, and this is the term where the A input's a 1. So it's that straightforward. You could have reasoned this out without drawing this truth table, but we drew the truth table anyway. So this circuit, once again, I don't think I want to draw it because it's just takes up too much time. But it's going to look something like this. It's going to have 4 AND gates in there. The outputs of the AND gates are going to feed into this OR gate. And for example, this is going to be A, B, C, D. For this first term, we'll do the first term. A has an inverter, B has an inverter, C has an inverter, and D doesn't have an inverter. That works. I can reuse this A bar term. Anytime I see an A bar, we'll need to complement the D later. Once again, I don't feel like drawing all the signals in here. I don't think it's very instructive. Once again, this circuit here is yet another model. So this equation is a model of the circuit. This circuit diagram that's not that fixed, we'll just call it a circuit diagram. That's not complete is a model of the circuit. The black box diagram is a model of the circuit. Truth table model of the circuit. 4 circuit models up here, each giving different types of information. Some are appropriate in some cases, some are appropriate in other cases.